Dude,
my laptop.
What's up, Scotty? Hey.
Anyway, we can just. How do you guys want to do this? Do you want to do like questions first, or run through just basic concepts first? Questions along the way.
Basic concepts.
We like that better? Okay.
Money.
Yeah, it's on. It's somewhere on Learning Suite.
Yeah, video?
It's like not
This will
super.
make me not talk, so you can't.
It's on today. I think it just says like midterm study guide.
recording? Okay.
Yeah, so
I
like,
am starting recording.
like this kind of stuff, like we just like copied and pasted it just so we can have like, you know, like a guideline for us to talk about stuff.
Read it.
Barely.
Is there a way to get rid of that glare?
Yeah, we'll just start going through it. So you need to know
Hey,
this stuff. Yeah.
sorry, it's pretty bright. I wonder if we took the lights down. Like, you can't really see it in the.
Is that better?
Let me just try to
I
zoom in
got
on
two
the
switches to play
screen.
with right here.
Maybe.
Oh, that might
Oh.
be. Nope, right there. I
That
think.
looks pretty
Sometimes
good.
it looks okay because we're gonna post the slides in the video.
Oh, okay.
Oh, nice.
Yeah.
That should be
You
fine.
can download the slides and then watch the video.
You think that's annoying, just seeing the text?
It's probably okay.
And some of these slides might be a little out of order. I know we have some pictures of collision domains at the end. So,
I don't think he's
I don't know, we just kind of threw them all into one big thing. Anyway, you guys have anything to say about this one?
No, we'll go through these, I guess. I mean, this is just kind of basic. Just know the difference between amplifiers, repeaters, hubs, switches, routers. Do we have any slides in here on that?
I think we do. Sorry, like I said, they're a little out of order. Here we go.
Okay, go back then. Just go back to them. Let's
Yeah.
start over. As long as you do, as you can say. And then we'll talk about collision domains.
Yeah, we had pictures of that at the end.
Bandwidth is good.
Some of these are basic, just like definitions.
We talked about all these, yeah.
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 For elements of data communication systems, I don't think we have them listed on here. Does anyone know off the top of their head? I think it's like protocol. There's data to transfer. There's a medium and like a receiver.
For receivers, sender, or protocol and medium.
That's it. Yeah. Sorry, I forgot sender. Yeah. Look those up. Sorry.
Just know that those are the elements.
That's like
of
a
data
really-
That's really all you need to know. That those are the elements of
It's a
it.
pretty straightforward question.
Yeah.
So, if that is a question. I mean, we looked at the test when we made these, and he said he's probably going to change a couple questions, but for the most part, they'll be pretty similar, I think.
You say this again? Sender, receiver?
Yeah, sender, receiver, transmission, or not transmission, sorry,
Protocol.
media and protocol. Media is in like, what's it going through? Like, is it wireless? Is it going through the cables? Like right here,
So,
transmission media.
Medium or media?
Medium.
Both.
Media
What's it
is
now?
go for me.
Probably medium. I'm not sure why I did media. There's probably a lot of typos too in that because I made it really quick. I mean, the couple slides I made.
I think medium is
You'll tell
usually-
which ones I made.
I think medium is usually, but
They'll be
yeah,
messed up.
it's the same thing.
You will need to know the differences between these.
Sorry, one more time. You said sender, receiver, medium, and
Protocol.
Protocol.
Like you need to know, like, are we doing like TCP or yeah, UDP? So we do have these three different ones. Yeah, this is a little funny order. Let's go.
We can show the overall layers first.
Okay, yeah. Let's do layers. So frameworks. This stuff is kind of annoying, but I remember there being a lot of questions on it. The models, I mean, I think you would expect a lot of questions on this because he always like tries to tie it back to it in class, like, oh, now we're in layer 4, you know. So there's OSI model, DoD model. You need to know what they are and how they relate. This slide kind of shows how they map up against each other. OSI is 7, DoD is 4. Know the names for each of them and how, you know, like network consists of, in the DoD model, the physical and data link in the OSI model.
So there's two important things. Go back to
Okay.
There's two important things to know with the models. Number one is what they call the different data types on each. So this is on the physical level, it's called the data link, it's called the frame. Network's called the packet, right, going all the way up. That's important. And then also which protocols, we have a slide later, but which protocols fit into which layer. Like
Yeah.
where is the TCP protocol? Which layer is it?
There are going to be questions that says like when you ping a computer, what protocol is that? Or, sorry, not protocol, what level is that running at?
Layer 3.
And I think, I
So
mean, I
you
can
need to
show you
look
right
up
now.
which one,
This is honestly a crappy picture that I found, but it shows the idea. I think there's one better, a better one in your book, if I remember right. Yeah, honestly, this picture kind of stinks. But like, here's like ICMP, that's like a ping. So that's like, this is the DoD model, so that's like the internet layer, which if we look back, is a network layer. Which makes sense because pings use IP logical addressing, or I mean ICMP, which is what ping is doing. So yeah, so the layers and the responsibilities of each layer, like this one just does the physical connection, and then what Josh just said, like the different data types at each layer, like bits, frames, segments, packets. Did I get that in order? Oh, packet segments, sorry. And then what protocols and services are happening at which levels. And yeah.
So what questions do you have about the models? Anything? Yeah.
Do we know the data types and protocols for each layer of the OSI and the DoD model?
So there's going to be the same. You just need to know it for the OSI model.
Yeah, and if you know how they map over, then you can know like.
This kind of shows where they show up. But I think as far as the test goes, it will ask you
Yeah.
physical data link network.
Because it does get a little iffier here. Like it's network in the DoD frames or bits, but it'll just be OSI.
It'll be just OSI as far as the data type good question. But
Because we generally like the OSI model more, I think. At least
well,
in his class.
yeah. You guys don't need to know the difference is that the OSI model is actually used as a conceptual model to understand how networking works. It was built by a bunch of education people to understand like conceptually the steps of networking. The DoD model was actually built directly around protocols. So every single protocol will line up with one of these layers. They don't necessarily map directly to the OSI model, it's pretty close. Usually when we talk about protocols and what layer they're on, it's going to be in reference to the DoD. You guys don't need to know the difference between that, but essentially that's why they don't always map up directly across, is because you can only get it close, but like I said, all you guys need to know, the bits frames, look at those, layer them up, and then just know the layers in order. And then know which protocols line up with which layer of the DoD model.
Yeah, and also like go through like the slides that he showed in class, because I mean I just grabbed these from the internet, and so like because I don't want to look through all of his slides. They should be the same, but just in case like there was.
These aren't incorrect, but they might not be as detailed as
Yeah,
the others.
and I'm sure like when he like writes the questions, he like takes it from his slides. But we just wanted to have like something to explain better with.
Could you explain more about data types?
Like, what do you mean? So this is data type, that's literally just what it's called. So on the physical level, right, that's going across like a cable, like an Ethernet cable, you're sending bits, you're sending ones and zeros. Like literally electricity, they call it bits. On the data link level, you're sending what are called frames, and if you remember in Wireshark, and we have a capture here later in Wireshark, you could like look at the frames. And then on the network level, you're sending packets. That's what you guys would have worked on most of the time in Wireshark, is a packet, like a packet header. And then in the transport level, it's just what they call them as a segment. And essentially, it's every time you go through one of these layers, I don't know if you talked about like when you're sending and receiving, when you go through each one of these layers, it's like adding another header onto it. It's like when you put the cards inside the envelope and send them. It's like literally just adding onto it, and then when it gets to the end, it'll strip it back down when it gets to the receiver. So those data types, that's literally just what they call them. There's nothing different except for the fact that it's adding more information on each layer, but you just want to know what they call them. So if I tell you we're looking at packets, you know that we're looking at stuff on the network level, right?
This picture kind of helps some people. Honestly, I don't really get it.
Yeah.
So like, if you're sending an email, it'll have like your plain text right there. And then it comes down to the UDP layer, it's going to add a header onto that. And then when it comes down to the next layer, it's going to add another header onto that. And then it comes down to your layer 2, it's going to add another header onto that. And then it sends it over on the internet, and then the other computer receives it. It looks at your header, and then it just strips those away until it pops back up into your email program. Does that make sense?
Yeah.
Let's see. Yeah, I would try to find a better picture for this. Well, I don't even know if there is a picture, to be honest, but like,
Are those the protocols there?
Yeah, but I mean, this includes like a bunch of random crap you don't care about, like what is this, like
Yeah,
LVP,
like if you haven't, like, go back to it, if you, like, our ARP, like, he's not gonna talk about that, right? You guys haven't gone over that in class, but like,
Yeah.
ARP, you guys have gone over ICMP, TCP, UDP, IP,
Yeah, there's a couple.
maybe even like FTP, Telnet,
You
and
mentioned
SMP, like, those are like commonly known things. Like, if you never heard of it, like X window or FTDI token, like, I don't even know what the heck these are. They're probably not gonna be on there, but like,
Yeah.
so,
You wanna go over like
the common ones.
Yeah, is that what's next? Yeah, who wants to, does anyone remember what ARP is? Yeah,
Like, explain it?
yeah, just cause like we don't have a slide for it, but I think we should talk about it real quick.
Oh. ARP is basically address resolution protocol.
Yeah.
Basically what it does is it maps an IP address to a specific MAC address.
Yep.
And it does that because sometimes certain hosts want to grab a MAC address, and so they send a request to the network. And then the network uses ARP to send a MAC address in response.
Exactly. So if you guys remember the lab, that's the one that says like, you like send like the ARP request and it says like, who is at some IP address, and then it says, oh, some long MAC address is at this IP address, and it's kind of go back and forth. That's what the ARP is. ICMP, I forgot, I know the P stands for protocol, but that's what ping does, it's just sending messages, little like test messages stuff. I think we have a slide later on TCP and UDP because the differences between those are important. I don't, this is a little, taking like a step away from this, but for the test it's really important to know your labs. Like if you just like study like just the slides and you like kind of forgot what happens in the labs, like you'll be lost on a couple questions, because I think there are questions on like, what does this, like how do you do this in the firewall? Like it's not going to be super hard, but like maybe a command like how to copy the running configuration file, or what do you type to get into privilege mode. I mean there's only like 5 commands in the lab that you do for the firewall, but I remember on our test there were questions like that. Maybe he took them out, I don't know. Also just like, there could be a question, like I just said, like the who is at this IP. You could have a question where it says like, write out basically what an ARP request does. And if you just know, oh, it's on this layer, that's not going to cut it for those kind of questions. You really want to be able to get in depth with those kind of things. So just go over your labs, it will really help, yeah.
Is it super important to know what all of these stand for, do you think?
No, I don't think that's
I would
gonna
just
be
say like TCP, UDP, ARP, ICMP.
Well, like, do you mean like what the full?
What the full, what
I don't think so. But like in this case, like knowing the like address resolution protocol, you're like, oh, it resolves addresses. You know, that could be helpful. But
There's not like any vocab, like what color stand for.
yeah, because I don't know what
more important to know what
TCP.
it does.
Yeah.
Exactly. Yeah. Okay. I think these next couple slides.
Yeah, let's go over this one.
Yeah, this is. It's not really part of the layer anywhere, but these are just devices you need to know. A lot of these, like, we don't work with them as much anymore, because as like technology has advanced, they've kind of been like packed into one. So like, you know how like the router is also a firewall, it can be like a switch and all that stuff. So these might be a little more conceptual than you might like. But
Do you guys remember going over these in class? You guys learned
Yeah.
about this? No? Getting a lot of no's, okay. Who, so, repeater and amplifier, who knows, what's the difference between a repeater and an amplifier? Who wants to tell me? Someone's got to know. Yeah.
I'm gonna take a stab at it and
Please.
just say repeater, an amplifier does the same thing as a repeater, but it just does it on a bigger scale. It makes it bigger, it amplifies.
Yeah, Drex.
Close, so they both amplify it.
Oh,
Okay.
repeater amplifies as
Well, yes.
well. So it's not just like repeating the same frequency.
It is repeating the same frequency, but if you think about it, it amplifies it in the sense that even if it gets it on a weak signal, it's going to send it out with whatever max force it has. So it amplifies it in that sense. They both take a signal in and transmit it. The difference is right there. An amplifier literally takes everything and amplifies it again. A repeater is going to take in the information and essentially clean it and send it back out. It sends out just the pure information, so there's going to be no noise, no attenuation, nothing like that. Yeah.
So is there a concern that an amplifier will send a more convoluted message than it
Yes.
receives? Okay.
Yeah, I mean, possibly, like,
It'll send exactly as convoluted a message as it receives. Whereas a repeater will send a cleaner message than what it receives.
Oh, okay.
Because it'll clean out any noise.
So why would it ever use an amplifier?
Cheaper,
that's what I was
don't
kind
know.
of saying, like, a lot of
Yeah.
these, like, don't even get used
That's the thing, it's the same thing with a hub.
very much, yeah.
But I mean, no one uses a hub anymore. Who knows what a hub does? What's the difference between a hub and a switch? Yeah.
A hub will not direct it to specific computers within a network. So if a message comes into a hub, then everyone in the network can see it.
Yeah.
Exactly,
As opposed to
yeah.
a switch will
Right there,
direct it.
broadcast everything.
Yeah. So when a hub receives a message, it's going to send it back out on every single port. And like a switch, which when it receives a message, it'll send it back out on just the interface that it needs to go to. That's the difference between those two. And then
And also, like, it says right here, the switch, like, breaks up collision domains. Because the hub, like, broadcasts everything, it doesn't break up collision domains, I don't think. Am I right on that?
it doesn't.
Yeah,
We'll talk
so, like-
about collision domains later, but no.
Yeah, we'll get to it, but like, let's say like a problem comes through the wire, like it'll just like shoot it out everywhere. Where a switch, can kind of break that up into more safer places, which, yeah, we'll get into.
And then, so that's a hub and a switch. Everyone understands those two, right? And then a router, what does a router do? It's easy, who knows what a router does?
It just like sends like data packets from like these like computer to like the internet and stuff, and that's like where you have firewalls come into place. Like you can put firewalls in between like what a router is sending to somewhere else. It sends
Yeah.
it through ports.
Yep, so a router has what's called routing tables, and essentially, just like it says, it'll forward packets between networks. Whereas a switch will operate on a single network of computers connected to it, and now of course a router has the routing table, so it knows where like the next step should be for a packet. Not making
Quick question.
Yeah.
Do any of those devices belong to any specific layer in the
Yes.
OSI model?
Yes, they do.
Okay.
Should we take anyone want to take a stab at it where they belong?
I don't want to take I don't want to take a stab on it. I
No, that's
just want to
fine.
clarify something before we go there. Just the difference between a switch and a router, the way I'm understanding it is a router can access networks outside of a local network, right? So it has like
Yes.
an extra capability on top of a switch.
Yeah, that's where the routing tables come into play. Whereas a switch just knows what's connected to it, essentially. A router knows where to send stuff if it doesn't know where it's put, essentially.
So basically, we don't use any of those things except for a router these days.
It's all like built into one.
You
I'm
use
sure
all,
they
you use
might.
both, you use switches and routers. We don't use hubs anymore.
Yeah, they're-
It's good to know what they are for legacy purposes, just because if you want to be a network technician, it's going to be good to know what they are. No one uses hubs anymore. You do use a switch and a router, but they're usually built into one.
Okay.
So if you think about it, when you guys do your labs, not your sprint, but your lab, when you guys use that smaller box on top, so you have the one port where you get internet through, that's like your router port, and then you have those 4 other LAN ports, or like you one at home. If you think about it, there's a WAN port, and that's where you plug in your internet cable. Then you have those 4 LAN ports. Those 4 ports are working like a switch. And then the router overall is getting your internet and connecting you back out to the outside network.
Okay.
yeah, people might use repeaters and amplifiers like in big enterprise stuff, but I don't really know.
Or if you have a really big house.
Yeah, it's repeaters everywhere. What was the question about?
Which layer?
Well,
Oh yeah,
layers.
where the devices belong. Did you have that?
Yeah.
You got like really.
Well,
Oh, who? I was just gonna say one.
go
yeah,
for
go
it,
for
yeah. Say it.
So the router, because it's using IP addresses, it's on layer 3, correct?
Yep.
Which
Yes, and that's like a perfect way to think about it, or how to like remember it and stuff. So like it's like routing between like IPs and stuff. So you just think like, where do IPs fit in? Oh, IPs. That's like logical addressing. That's level 3. What's level 3 called again?
Network.
Network. Yes.
And the switch is a layer 2. It only remembers MAC addresses. And your hub, amplifier, and repeater are layer 1.
Yeah, because like this hub, like it just broadcasts everything. It doesn't like it doesn't keep track of the MAC addresses it's connected to. So I mean, it's not really at that level 2 capability yet. It's just a way that you can like try to remember it. Because just like memorizing it probably won't. I mean, it's not as easy. Yeah.
Could you explain what a collision is again?
We're gonna get to it later.
Okay.
Yeah.
So why does a switch and a hub on different layers, even though they do the same thing, except for one broadcasts and one has this a unique
Remembers.
Because the hub does not even remember MAC addresses,
Yeah.
whereas the switch does.
Okay.
So the switch is smart enough to say like, oh, you're trying to send to computer A over there, I can like send it to them. But hub just says, whatever I get, I'm just gonna push it out to everyone else. Yeah.
You might be getting to it, but what about bridges?
Bridges are like the switch.
Yeah, I think those are the same, aren't they?
Okay.
Back in the science, he calls a switch a multi-port bridge.
Oh yeah, I think isn't it like a bridge just has like one or like 2 ports or something?
Yeah.
Okay.
Yeah, good question though. But I really doubt it'd be on there.
Thank you.
Yes.
It uses our, that's exactly what it does, yeah. So like the first time, so a switch, so your router stores routing tables to know how to send it to different networks. A switch stores MAC tables. And that's what like when you do, that's what you guys had to like in your lab, I don't remember this, you had to like send out your ping and look in Wireshark for that who has, or whatever, who has this address, and then you would like clear your table and then do it again, it would send it out. But then if you didn't clear your table, it didn't ask it the next time, because it stores it. So if it has a clear MAC table, it'll have to ask that, but then when it asks it the first time, it says, okay, this IP address is stored with this MAC address, I don't have to ask next time.
So both your computer and the switch will both kind of have those tables, or the computer not hold that at all?
I don't think your computer holds that, it's small.
Yeah.
Well, it would hold, does your computer hold a MAC table?
It has the ARP cache.
Yeah, then what does the switch hold though? Because the switch has,
It just has a table of facts.
that's a good question. It's not on the test, but that's a good question. That's a good question. I'll find that out for you and let you know. I'm not sure exactly what the difference between those 2 tables is.
Yeah, we're gonna push forward. We already talked about some of the devices. Yeah, right here, hubs and repeaters. That's physical.
Oh wait.
Oh,
How does
yeah.
the bridge?
Is there a repeater level 1? Did I just say that?
Yes.
Yeah, you did. What did you say should be on? Oh, sorry. Yeah, you can probably ignore bridge. Okay, that's pretty basic. It transports the data. I don't know why you need to know this, but you need to know this. I mean, like, coaxial cables, like, I think it's important to know they exist, but, like, why you need to know the names for the parts is, I don't really know, but you didn't need to know unless you took the question out. And it's really easy, just know the parts of it. Yeah, that's all I can say on that. Not positive if you need to know the difference between these, but it's not that complicated, so you might as well. So yeah, the S stands for shielded. As you can see, there's like this little blue part. I think the book lists like some pros and cons, but basically like there's like less EMI like interference. You get better I don't think transfer rates, but
There's less noise.
yeah, that's what noise and like that stuff. But it is more expensive, so there's always that trade-off. And then there is fiber too. Didn't have a picture for that. And like the book gives like tables with like, and maybe even like Dr. Kettle slides like for like the comparison between the different rates and stuff. Like I don't think you need to memorize fiber can go this fast, but you should have a general idea of like which ones are faster. Like I said, like a general idea of like the trade-off between these two. Maybe you should know the trade-off between like using coaxial versus like twisted pair. Sorry, these are twisted pair. We didn't label that because there's pairs that are twisted. They have the, you know, just the network jack that you imagine, which is like this kind of one. Yeah, so then like the general trade-off between like speeds and stuff, I don't think you need to memorize the limits of speeds for each of them. With fiber too. Fiber's fastest. You can remember that. And also the trade-offs between using fiber, like fiber's more expensive, or this one's cheaper but it has more noise, that kind of stuff. Questions on that? Moving to the next layer. Okay. So data link, layer 2, we already talked about the data is a frame. We have our switches. We have MAC addresses, which is media access control. So layer 2 is physical addressing, and that's what MAC addresses are. So that's, you can remember those two go together pretty well. And I think we have, there we go. So when we talk about the data as a frame, just so you can like remember exactly or visualize more what a frame is, this is a frame. I think in one of the labs you like, in Wireshark you kind of click through the frame and look at, you can see the destination, you can see the source, you can see the payload, right? Remember that? So, yeah, that's important to know. It's also important to know how, that's pretty fuzzy, how MAC addresses are. Like there could easily be a question that says like, how many bytes is a MAC address? How many bytes are, how many bytes, yeah. And that's honestly like an easy question. As well like how it's split, the first 3 bytes of that identifier. And then like specific, how that breaks down.
There's no difference between bits and bytes.
Yeah.
Okay.
And like, how are like MAC addresses written in? Are they like, I mean, can you like visualize what it looks like? Yeah. So it's all written in hexadecimal. So like, here's a perfect example. So like, if you forgot that it's 6 bytes, and you know the math for hexadecimal, you can just like count out and say, oh, okay, this is going to transfer down into 6 bytes. And then, you know. Which, if you don't know the math for that, we will cover it later. Not specific for hex, but we're doing binary decimal. But hex is easy once you understand like numbering systems. Questions? Yeah, I'm kind of going pretty quick because we do have a lot to cover.
So there was something on the Kahoot today that said the last part is the name of. Could you say that bottom part in different words than what they have?
Yeah. So. If like you're sitting, if you have a Mac and sit next to someone with a Mac and you do like a, I forgot the command on Mac for get your MAC address.
ipconfig all will give it to you.
But for a Mac, is it ifconfig?
Oh, I don't know.
Yeah, well, because like Windows is a little trickier because like, you know, there's like Lenovo, Dell.
Yeah, so
Isn't that IP config?
Yeah, so I think Macs will be the same, but basically it's like each like manufacturer. That's the word. Sorry, yeah. They like have this organizational unit unique identifier, but they're not like all unique. Like Lenovo probably has like 20 because they make so much crap. And like Dell.
well, it's the manufacturer of the network card you have. It's not your computer, it's a specific network card you have. So maybe Intel made your network card, maybe IBM made your network card. It's the specific network card.
Yeah, I got that wrong, but yeah.
So with the 2 different parts, which one's actually the first 3 and the second 3? Because the numbers go opposite.
What the? That's weird.
Yeah, that is confusing.
This will be the first 3. That'll be the last 3.
I would ignore this first, second,
Yeah, I don't
third,
know what
right?
that's about.
Yeah, so it's so if you're reading it left to right, it's going to be the first 3 and the second 3 left to right. That is
So yeah, this is the OUI, and this is like your the one
so
specific
go
to your
back.
network.
So let's say that this, so 001FF3, let's pretend that's an OUI for Intel. That means that any network interface that starts with those, you know it's going to be made by Intel. So Intel has Intel probably has multiple since it's such a big company, but if you're a company making network interface cards, you might have just one organizational identifier, and all of your MAC addresses start with that. You know, you can go on, there's websites where you can like go search, like look up this OUI, and then you plug in your first 3 digits of your MAC address, and it'll tell you who made your network card or whatever. And then this last part is just like, it's random, it's just specific to, that's how they specify.
Yeah.
That's what makes it unique. But these first 3 are going to be the same for every one of that, like, MAC address of that.
So what's a possible question that you would ask with that knowledge?
Yeah, so don't go super deep into this, but he might ask like, what do the first 3 bytes of a MAC address
Yeah.
specify? It's the organization.
Like I don't think he's gonna ask you why they have those, because like, I don't think you talk about why.
Yeah, it's not gonna go, like, we're going a little bit more in depth than you need just to help you solidify it, but he might ask, what do the first 3 mean, or he might ask, what part of a MAC address is the organizational unit identifier? Oh, it's the first 3 bytes. It'd be something simple like that, if anything.
Yeah, and definitely like the idea behind it, like why we need a MAC address, like is MAC address physical or is it a logical address, like that kind of stuff. We already said it's physical, so, yeah. Okay, yeah, format, how, when they're used, we already mentioned that with the ARP stuff. So network, we mentioned this, packets, routers use those because routers go between networks and they're just dealing with IPs the whole time. They have their little routing tables. And here, it's a packet header. Is it packet header?
I don't think.
Yeah. This is from Wireshark. You probably saw this in your lab. Yeah.
So what's the biggest difference between a packet and a frame?
What layer they operate on.
Yeah.
Really? So they're pretty much.
It's really, like I said, those are literally just names that people have given them so that we can specify what we're talking about. Like,
Okay.
it just adds more information to it. But I mean, it all breaks down to 1s and 0s if you think about it at the end. So it's literally just adding more, just adding another frame on, or another like piece of information onto it as it goes through those different layers.
Okay.
But yeah, the biggest difference is just which layer you're on, whether you're working on a physical layer or a network layer. If it's going across the internet, it's going to be a packet. If it's just going across from a switch to a computer, you know it's just going to be a frame or whatever working on the physical layer. So.
And yeah, and there are like cases when like maybe you are like going between different networks, so you add like more headers. That's what it usually comes down to. Like if there is a change, like the one picture we had with like the different blocks, is that you have like, oh, here's like the MAC headers, and then here's like the IP headers. Yeah.
And I wouldn't worry too much, but I don't think there's any way he asks you a question where he's going to like want you to break down a packet, like read all the information in it. But it is good to know, like I said, which layer is what it's called on each layer, that kind of idea. You're not going to have to read a Wireshark thing and like have to break it down like this.
Wasn't there a question I asked about like the headers or something?
What about it?
I remember. I remember there's like a picture. I'll try to find it and then maybe I slack it out. But it like show like the breakdown of the headers. I remember if there was a question. I remember studying it though, whether we had it or not.
Okay.
I'll let you know on that one. If there's like a picture in your book from the slides that shows like the breakdown of the header, just know the basic idea how like they have, you know, like a source and a destination and like the data and then maybe.
Oh, like what information is contained in it?
Yeah, I'm thinking about that Mac one we already looked at. Sorry.
Okay.
Okay, layer 4 is transport and segments, which are just big strings of packets. And you looked at this in your lab with the TCP UDP lab. What was that? And you could like see like the different packets coming through when you like, isn't that the one where like you sent like the declaration of independence or whatever? And so it's really big, so like it breaks it up into like a bunch of little packets, which are like just kind of segments as a way you can think about it. Definitely know the difference between TCP and UDP. Who knows, just like one really basic difference off the top of their head?
Biggest difference from these two.
Yes. Any one of you two.
There's somebody in the back.
Whoever yells it quicker.
TCP checks that it is received and sends back a confirmation, so it's a little slower. You make sure all the packets get there. UDP just throws them and hopes they end up there.
Yeah. And so remember like the TCP handshake?
That's like the
Sync app.
Yeah, maybe not Waco. I don't know what
I-
else. It's like SYN,
Whatever.
SYNAC, and ACK. Yeah. Know those. Know just like the idea behind it. Yeah.
Do you need to know the receiving side, the like final like sequence number with the ACK number or something like that?
I really don't.
Okay.
Maybe on the final. I don't remember.
I don't remember it,
Okay.
but
I would know SYNAC. Yeah.
definitely know that. No, there's a couple more like differences between the two. Someone mentioned like speed because you're doing like that handshake stuff, like speed goes down a little. I think is there another difference?
I don't think it's on the test. If it is, I won't
Okay.
confuse yourselves.
Yeah.
Just
The
know
other
that
one
big
it
difference.
gave in the book was that TCP allows you to go back. So like YouTube does TCP, which allows you to go back because it orders the packets. So you can like
Yeah,
rewind,
yeah.
whereas
That is
UDP
true.
you can't go back.
Because they are like keeping track of the like the, I think that's what you're talking about, the sequence numbers. So I don't think you'd have to say like, give me the sequence number for this, because it's like generated randomly most of the time. But the idea behind it is like, it is ordered. So like, playing like email and stuff, that's TCP, because you don't want to lose any piece of that email, because then it wouldn't make sense. Streaming stuff like Netflix, probably UDP, pretty sure.
Actually uses TCP.
What, Netflix?
Yeah.
Yeah, Netflix is TCP. You don't want to lose anything, but like a live video stream
Okay, yeah.
would be what? Yeah, like Google Hangouts. Because you don't care if it flashes a little or lags a little. You just want it as fast as possible. Whereas if you're watching a Netflix show, you don't want it skipping every other frame. It would look really laggy. Right?
Yeah,
drag it
so
back.
my Netflix like skips it a bunch, so.
Netflix is
I
probably
just-
on UDP.
I just assumed, yeah, maybe my Netflix is on UDP. Mine's special. Port numbers, we'll get to that later.
Just know this layer does support.
Yes. Did you hear that, guys?
Yep.
This layer uses port numbers. There's a slide at the end that does have ports that you should know, but also know that like you can do anything on all the ports. Like you could say like port 80 is like HTTP, but you could run it off a different port, you know? There's nothing like super special about it. I think I remember we had a question like that. So that's just like a, what do you call it? No, no.
Yeah, it is. So there is.
I mean, you're right, but what was my wording?
Gateway.
No, these are all like way
I'm
off.
just getting confused.
Yeah.
Don't worry about it. We'll talk about
Conceptual question. That's what I was trying to think of. Sorry, it's like a conceptual idea that just like will help.
Can you repeat that conceptual idea?
Yeah, so it's the idea that like, we're gonna go over some like port numbers. Like FTP is like 20, but like you could like set up your stuff in a way that you're running FTP off a different port, or you can like say, like I'm gonna run my website which defaults to like port 80 for HTTP. I'm gonna run it off like 5002, you know. So just that idea, you like, is just good to know that they're not like special in any way. Okay, I'm wondering if we should do like subnetting at the end, or should
Yeah, skip ahead. Let's get to the rest of the slides.
because we're gonna do like stuff.
If we want to do that, we can go over the classes. If we want.
Okay, we'll do like basic IP stuff, and then we'll actually do like whiteboard examples of subnetting after, just so we don't have to like keep going up and down with this. But IP addresses, I think you should know what an IP address looks like. Do you remember which one like we generally use? IP4, IP6?
IP4.
Yeah. I don't think you guys there'll be a question about IP6, but why are we like is IP6 a thing? Like what's wrong with IP4 right now?
We ran out.
Yeah, and that, you should know that, just because, you know,
It's on the test.
even though it's like, however big, I don't know how many there are, but there's a ton. We're still running out because everyone has internets and stuff.
Everyone has internet.
Everyone has internets. How many networks, how many hosts belong to an IP? We'll get into that with the subnets. Private versus public. We have a slide, and these other things we'll go to in the
Yeah, we can probably just go through the slides. So, okay, classes. You guys remember talking about the different classes? So there's a difference between classes and private IP addresses. Make sure you know that, okay? So these aren't the private IP addresses, these are classes. And
I would probably ignore E,
ignore E.
and maybe even D. Maybe D though, but definitely forget E.
Do you guys remember these at all? Like, did you guys talk about classes?
Yeah.
Briefly.
I honestly don't know why we still teach these, because classes like haven't been used since like 1994. I've seen. Like I guess we just teach them so that we know for like legacy, like for network stuff. But ever since they came out with subnetting, classes aren't even like used anymore. But it is good to kind of understand the idea between the different classes. I guess we teach it. So it's based entirely off of the first bit. of the number, but just know the ranges. Class A, 1 to 127 essentially, but it stops there. Then it skips. Why do we skip 127? Loopback address. Class B, 128 to 19, everything short of 192. Class C is 192 to 223. Class D is 224 to 240. And yeah, you can probably range.
Yep.
But just know those ranges. I don't think you need to know these exact numbers, like how many hosts and networks.
But just the general idea that like a Class A network,
Yeah, has more.
there's not a ton of Class A networks because it's only like, well, just like look at there's like less, but each one is going to have a ton more because you can use like all these numbers out here to create unique ones. But, like the ones that like in your house and stuff, or not like in your house, but like this 192 probably looks familiar because, well, actually we'll just get to that right now.
So that's
from Wikipedia if you want to.
This is Class A's again. This part is important. I think this might be on the test. I don't remember exactly. So the classes are defined by the first bits. So a Class A address will always start with a 0. Class B address starts with a 10. Class C 110, and Class D 1110. They're called the most significant bits. They're the leading bits right at the beginning.
So like that's why Class A goes up to 120. Like it doesn't hit 128 because once you hit 128, you have a first bit.
A 1 in there. Does that make sense? It would no longer start with a 0 once you get to 128, because a 1 would be the first. That kind of makes sense? Okay.
And then this also just goes over like more addresses. I mean, right here, there's only 128 networks, but each network has like 16 million addresses. For Class C, we have like 2 million networks, but each network you can only have like 200 or something.
And again, I don't think you need to know the numbers, just know, yeah, Class A, less networks, more hosts, and then know the ranges. 0 to 127.
And we will show you the math later on for like if you do want to do that. It's pretty simple. Okay, this is a private IP address range.
These are more important. These are still in use today.
Yeah. So this probably looks familiar, right? All your IP addresses until like you changed them in the lab a couple weeks ago have all been like a 192.168.0.0. And so, do you guys understand why that's a thing?
What's the point of a private IP address?
It's used on your local area network to identify devices.
Yeah. And so like, oh yeah, go for it.
Well, yeah, so the point is that anyone can use these addresses without like talking to like it. Like normally when you get a public IP address, you have to like register with like an internet registry or like the ICANN or whatever. But anyone within their network can use these addresses. So they're not going to be out on the public internet. They wouldn't be like routable across the public internet. And so that way it kind of frees up some IP addresses so that you on your public network can just use these freely and not worry about taking someone else's IP address already.
Yeah, because like if you look at it, it's like, you know, this supports like 16 million hosts, or like Class C only has like this many hosts. Well, like I'm sure there's more people that have like an IP that starts with this than like 254, but it's because like each one has like maybe a Class B address on the outside, but within their like house or within their university or whatever, they're like have all these private ranges.
So know the ranges.
Know the
on
ranges
these again.
Yeah. So like each one, like no, Class A goes from like 1 to 26, but a Class A pub or private address goes from like just 10 up. Well, not up all the way, 10 to until 11. And then this knowing the subnet mask helps too.
We'll go into subnet.
But we'll go into that later, yeah.
So what questions? I feel like we're talking over ourselves. I'm confusing myself.
So the Class A, B, and C private IP addresses are contained within the Class A, B, C IP address ranges?
I mean, technically they are, but I wouldn't think about it like that.
Because they're separate.
Like they're two different things. Like you look at classful addressing, go back. These classes, this covers like every single IP address that ever existed, right? And it just like separates it into one of those classes. Whereas private addresses are like, these specific addresses are not to be used on the public internet.
Yeah.
So technically they are contained within a class of address,
Yeah.
but they don't necessarily line up. They might line up.
Well, it's because like the private C like starts with like 192.
Yeah.
So if you look at the other table, you're like, oh, this must belong
I think
to.
they do line up,
the
but
public.
not necessarily on purpose.
Okay.
There are two separate ideas.
So I understand the private IP address range, but I don't understand subnet mask.
We're gonna get to that.
Yeah, we'll do subnetting so we're gonna do a lot of examples of subnetting.
And from what I heard, like, we didn't talk about that too much in class, right?
Maybe we should, let's hurry through this.
So, yeah, we're gonna- We just have a couple more, so.
Yeah, these will be good.
Okay, fun question. How many host addresses are needed for this internet?
So think about this on your own for like 1 minute. Look at this diagram, write down if you need to. Think about how many addresses. So this is how many IP addresses are needed on this network.
Well, what's the cloud?
Cloud's the internet.
The internet.
I don't know.
Are we good?
Yeah.
I heard somebody know the answer there.
I was thinking that too.
Wait, what's at 7?
So, the easiest way to do this is just
I think
to
it's
count the
coming
lines
out of
and
the router.
everything.
The cloud itself doesn't have one.
But a more intuitive idea is like,
I guess like.
just think of like your router, like you have like,
Send it.
just like we're saying, like the router might have like a public, I mean it has like a public facing IP, so you can like, you know, go out to the internet and stuff, but then like a private facing IP that like you are connecting to. So, when like, if you're on this computer, you do like your IP config or whatever, it says that your default gateway is right here. But when it goes to the outside, it has like an out-facing one, like if this was going out to the internet or somewhere else. So it's just like, that's how I think about it. Yeah.
So why does a little lightning bolt have 2?
What, this one right here?
Yep.
Yeah.
So it's just because like every like
Routers.
outward-facing,
I think it's because it connects 2 routers.
yeah.
Each router has a unique public address, so router 1 knows where to send it.
Okay, got you.
Because like this router
That
can't
zigzag
send over
could have
here
other
because it
stuff
doesn't
in
know
it.
what this like internal like addressing is like. So it just knows I need to send it to here, and then this guy will take care of it.
So why doesn't the cloud have one then?
So the cloud, because that's the internet.
Okay.
So
I see.
technically wherever you're sending it does have one, but it's not part of your network.
Okay.
It does look confusing, so you wouldn't
Yeah, it's
count
a
the
little
internet as one.
Got you.
But eventually it would hit somewhere before.
It would
hit.
eventually hit something. But
Yeah.
Okay.
So with this network would only have one public IP connected to that number 9 spot, right?
Yep.
Yeah, I mean, we were talking about this earlier,
We were
like,
talking,
why a company would
Maybe
do
one with
this.
7 too, or
But, yeah, if we think about like all of this is like, or sorry, all this is like a private network and this is like the outside, then yeah, this would probably be your,
But if it's like a large scale enterprise, they could have connected their own routers with public IP addresses. But I wouldn't think of it that way. I would say yes, you're right. The public IP address only goes out to the internet. This company just happens to have 2 routers in their office that connects 2 different subnetworks, but they need a separate private IP address for both of those.
okay, next one, very kind of similar. How many networks are needed for this internetwork?
Yeah, there's 1.
I say 4.
There are 4. So, similar idea between it, is just like, since this network, this router is not gonna talk with these guys, it's gotta go through this router, and that kind of consists of its own little network right there. And by network, like, we kind of mean like different subnets, which once again, we're about to get into. So they're on like the same, network. Alrighty. Yeah. Oh boy.
Let's just skip that. Let's go to the example. This
one?
Or back to this. This one I didn't lab. This is all you need to know about MapPad. You guys remember the example you did in the lab where it's like if you're sending a message to Google, tell me what the source IP address of the packet is and what the source port is, and then what the source. That I would just study that.
I'm pretty sure it's that exact question. I just gonna like they might change the IP, but you're gonna be
The
sending
different
some
numbers,
stuff
but that
to
exact
Google.
question is going to be on the exam.
And,
Yeah, it's going to ask you for the source IP when it leaves, the source port when it leaves, the destination IP and the destination port. And it's going to ask you the source, again, the port, the destination IP.
And in case like Kettle's going to tell you like the format of this exam, like there's like multiple choice and then like kind of like a free response kind of area. So this is the kind of question that'd be like, he'd have like a bunch of boxes and be like, this, on this step, label the IP and the port that's going to, and this, you know. So Any
It'll be
questions on
identical to
this?
what was on the lab.
Because like, I mean, you have all the answers in your lab, but like just for understanding wise, like, any questions? Yeah.
What's the difference between the default gateway and the public interface?
So a default gateway, they're the same thing, except for the default gateway is going to be an internal side of it. So when you go back to that picture that with the addresses, so so if you're this computer and you're trying to get out to the internet, it's going to make a request to an IP address that this has no clue where it is, because it's not like if you request Google's IP address, it only knows like what the IP addresses are within its own network. So it says the default gateway is where to send information when you don't know where it is, which sends anytime you go to the internet. And the default gateway is going to be your router's internal IP address, and then the public IP address is obviously what the router uses out to the internet. So this one would have a default gateway saying if I don't know where this IP address is, send it to the router, the default gateway. And sends it there, and then the router knows what to do with it with the routing table and sends it out to the internet.
No, so in that example, like, there's like, I don't know how many stages.
So did you have a question on that?
Yeah, kind of on the same vein, but with ports as well. Where the ports are and how that
This one?
works. When you're, no, the one previous, when he was explaining the
Go back to the default gateway.
The default gateway. Because ports are assigned, right? And that's how the router is able to send information back to the computer that's on the network. But what ports are assigned and how many are there?
So I think that is like actually part of this one too. With this like random port 1, random port 2.
Yeah.
So we can just like run through this like super quick.
Let's go through this, yeah.
So like we're sending like just a request, like HTTP request, we just want to load Google's webpage. So we got to send it to Google and it just got to come
Well,
back.
that's this green thing up there. So this is where we're starting with that green. So we're gonna source is gonna be whatever. Let's pretend that's Google's IP address. That's
the source is the computer's IP.
Destination.
I'm sorry. Thank you. Source is gonna be always that one's gonna be. Except for someone pointed out in the lab that that's actually a private IP address.
Yeah.
Which is confusing. So that is actually incorrect. That bottom one, that destination one, we're gonna pretend
Let's
like
just
that's a
imagine
public.
that's a 272.
We're gonna pretend like that's actually going out to the internet, because that is actually a legitimate mistake in the lab. So, but that wouldn't matter because it would just be that you're just copy and pasting numbers. Okay. Anyway, that's all we do in this class, copy and paste. Destination. So you're sending it out from your computer. Your computer chooses just a random port as the source, but it is sending it to port 80 because port 80 is HTTP. You are requesting a web page, and HTTP goes over 80. So you're requesting it. Boom! It hits your router. Your router now takes it.
Answer.
What is it? We don't know what the router is.
And it's right behind you.
Thank you, yes, what the server receives. So this is what the router sends. It sends the source, so the router takes it, and the router says, okay, I know that you want to go to port 80 on Google, but for the time being, I am going to give your computer a random port number. I'm going to give you port like 3000 or something right now, okay? And that's just for the router to know. But it still sends your request now from, so now this source is what? What's that address? Oh.
That's right.
Yeah, that's right. That's right, sorry.
Yeah, which is correct. So like,
Which it is.
So Google, when Google like gets it, it doesn't say like, oh, your laptop on the network. It doesn't know anything about this. Like it only, like Google can only see like your public-facing IP, and so that's why it gives you a random port. Because like, I'm sure all of us like. We might be on different networks because like we always do like funny things with their Wi-Fi. You know, it's a big university and stuff. But like, imagine we're all on like one router, like, and we all go to Google at the same time. Google's going to get a bunch of different like requests or like packets or whatever, but this same source, because we're all in the same like have the same like public-facing IP. We'll all have different random ports, and that's how it sorts out who goes back to. Yeah.
Yeah. So just along with this, though, I know it's not like it's up there. I just want to make sure I understand. So that random port 2 is generated in the router, and it's just that linking to the other port that's internal to make sure you know.
It's
where
linking to the address that's internal.
Okay.
Yeah. It doesn't. The server, your router, does not care about random port 1. It just cares about the source, your computer's IP address. So it links your computer's address to the random port that it creates. Should we like write down real numbers instead of saying random port?
No, that's
Oh, yeah, we
That
got
help?
I mean, it'll probably be like a 5-digit, like 3572 or something. That was 4.
You guys can, yeah.
And like on the test, you could write like a random number, as long as just make sure you put in the same, or it's just safe to say random port 2.
Are the IP addresses, would those be on the test, or we?
Yeah, those will be good. Like he will give it, and hopefully he doesn't do private ones. He'll say like,
just copy and paste what he said.
And then as you can see, when the server's coming back, and by the way, do you think this is like the real server, like Google's server?
No.
No, it's going to be like the same thing. This is probably just going to be like their public-facing router.
That doesn't
matter, but just like conceptually.
Okay, here we go. Let's keep going.
Yeah.
Now everyone get this?
Yeah, wait, I got a question.
Yes.
Yeah.
Your LAN interface, is that the same as your default gateway that's getting called when you go to the router?
Where?
LAN interface, it's right there.
Yeah, that's your default.
Oh, yeah, that's your default gateway. Okay, so you can just see, I keep pointing at the screen, I don't know why. These are just flipped, right? So Google says, this one's coming back from me, Google's web server, back on port 80. We're going back to that public-facing IP, to that random port number 2 that we got. Right, it's just the exact one flipped. We're going back, and you can see this is the exact one from their flip. Because now the router says, which computer inside my network sent that to me on what port? I'll send it back. It's important to remember, because you might say, well, this packet's coming from this router, so the source is here. It's not coming from here, it's coming all the way back from Google, right? So it's coming back from Google on port 80. So that's, I feel like that's where people might mess up the most. Yeah.
Pretty confused. Could you step through this one more time?
I can help you after if you want.
Yeah.
I'll step through it in 30 seconds.
Yeah, sorry, we just want to hit subnet.
Send out a packet. Well, maybe, yeah, should we just go on?
Yeah.
Talk about this after.
Read to the lab and
this
then
after.
talk to us after too.
So when you're sending the request to a web server, the destination is not your original source, it's your external facing router, but when it comes back, then the destination.
Yeah.
or
Well,
the
see how
source
like
is
our original
the full web server.
original request, the destination doesn't say send it to the router.
Yeah, but so like when it comes back on the end, you're saying your source is the web server itself. It wouldn't be their public facing router.
Well, I mean, it would, but in this case, they're the same.
Oh, okay, okay. That makes sense.
Because like we don't know the exact IP of like Google's server somewhere, but we just call it web server because since we don't know that, we don't care about it. We just call it a server.
All right, let's.
Okay, that's just the same picture. Miscellaneous.
Okay.
Know these.
Let's go back and look at this after.
Yeah.
Memorize the port numbers?
Yeah.
Yep, these are important ports.
I think these, maybe not TFTP. All the other ones definitely.
I don't think TFTP.
Have you guys done email yet?
No. I would still know that one though.
Yeah, I mean, you'll know it in like a couple weeks probably. And yeah, just know those. That's all there's to it.
Oh, there's one that's not on there too.
Oh, which one?
HTTPS.
Oh yeah.
Do you guys know HTTPS? Nope. Well, I'm glad I asked this. 443. HTTPS 443. HTTP is 80, but HTTPS is 443. 443.
Okay, let's do subnetting. Should we do it? I'm sure it'll get stuck. Okay.
Go back. We'll go over this. I don't know if there's anything on that. We'll do collision domains real fast. So,
Terrible memory.
look at this and tell me, let's say how many collision domains are in this. So these, you guys probably can't read this. This is a hub. These are switches.
Can
Those
you
are routers.
define collision domain?
Yeah, so a collision domain is when you are sending a message and there's another message being sent at the same time. And they hit each other. And the domain is like anywhere where that can happen.
I'm saying 3, 4.
So people think 4.
Alright.
Let's look at. I think these
Okay, the
purple
red,
ones.
the red is the, so this is confusing because this has broadcasting and collision domains. Let's talk about the collision. Red is the collision domains here.
Oh, red's, oh, I see it.
So on a hub, anything the hub is connected to is a collision domain. Because a hub will take a piece of information and send it back on every port. And if it gets something and it's sending it back on every port at the same time someone else is trying to send something, it's going to be a collision. Okay?
So anywhere where there's a hub, that's like the collision domain?
Yeah.
I mean like places connected
Yeah, so if you could have had like 4 computers connected on here,
And that would have
the
been.
collision domain would still be
No,
one,
they'd all be
it would
one.
still be one giant collision domain.
Because like if something bad happens between the two, it just like the hub just broadcasts.
Anything
it
connected to a hub is just one giant collision domain, everything coming out of it. Routers and switches, every single connection is a collision domain.
Because if there's like a collision right here, it's not going to broadcast it everywhere else like the hub.
Because the switch knows exactly where to send it.
Do we need to know exactly what happens to like reconcile collisions and like what happens?
I don't think so.
You might want to know the CS.
You might want to know that word,
CSMA.
CSMA/CD.
It's like collision domain detection and.
Just
multiple-
that's talking about collision domain. You would never have to answer a question with that, but he might write that in the question, and you know that it's talking about collision domains.
It's just like what the protocols do to like avoid.
I know that's in the book, and I think you guys have talked, but it's CSMA/CD.
Oh, we already talked about that. Oh, these could be on there.
Jeez, there's so much crap. Okay, it's not crap.
The book does a really good pictures of these.
Just look at the pictures of these and know which one is which.
Are they shaped like those?
I
Do they
forgot.
have pictures?
They have you want us to go over pictures?
Yeah, let's do.
Yeah.
They have pictures for all of them.
We didn't got
Well, I mean, like, on the test pictures. Oh, that one looks like a star.
It's a star. I know what it is. Shape
That
identification.
one looks like a mesh. Also, it's a mesh.
I'll just like try and tell you what I remember from ours. So like, if there's like that one, I think that one's like the mesh. Sorry. It's like everything's like connected.
That's a very confusing picture. We're just saying, here we go.
Okay.
Okay, put this back up.
Yeah.
Oh, that's like the exact pictures.
There you go. You don't need to know about line or tree. You probably don't need to know about fully connected, but it's pretty self-explanatory. Everything's connected to everything else.
Like, there's a star, like, you're saying there's like a router in the middle, and there's like,
Or switch, yeah.
what about the ring one, what is that one? There's just a bunch
It's like you have to send.
Ring is every, yeah. Yeah, you have to send it through everything. So that talks about in the book, you send these things called tokens. You don't know what token is, but know what it looks like.
Also know which one is most like the internet.
Star.
Wrong. Wrong.
Mesh.
It's this one. Because like, are you connect? Like, is every router connected to every router? No, but there's probably one like there's. I mean, sure.
Probably
like, it's
some
fine,
that are more important
that are
than
more
others.
important than others, and like some that are just like way out in the middle of nowhere. I mean, that's like kind of like intuitive, but also.
How is a ring functionally different from a bus? If it goes to every single.
Because it has to, a ring, it has to go through it. A bus just broadcasts to it. So on a ring, it has to take the information, receive it, and then send it again. On a bus, which is like a hub, it gets sent along that line, and every computer receives it, but they don't have to do anything with it if they don't want to.
And that's important to know that the bus acts like a broadcast too.
The bus is like what a hub is, yes.
Yeah, review those in the book. I think they're just like a couple sentences each. But a lot of times it comes down to they're pretty similar.
Okay, questions? Let's go. Is that it? Okay, let's do addressing.
Okay, who understands like binary to decimal, decimal to binary?
You don't do that.
Because if you don't, like subnetting will be extra hard until you learn it. But learning it's really easy, so you're fine.
Okay. I'm going to give you guys, let's do a quick example and then.
So who doesn't understand decimal to binary? Is everyone okay with it?
Yeah. If you guys want an example, I'm going to do an example problem right now. If you're okay with binary to decimal and subnetting, then just, you can go. We're going to do an example real quick.
Are you example of like a full subnet or?
I'm just going to watch.
Or just a binary to?
Good.
This will cover everything you need to know.
I'm more
This
than
one
helpful
question,
team
I'm
now.
just kidding. If you can do this one question, you're probably good.
After
Okay.
doing the Kahoot today, I got 3 of these.
Yeah, you told me that, but
Section 2 wasn't as bad. And everyone just heard me say that.
It's gonna be so confusing. Okay.
Okay, who knows
Section
what
2
this
is
the
so
end
sick.
Oh, you want live on?
It's way better than Section 1.
The port number?
It is not the port conversion. Is that better?
Yeah.
Oh, wow.
It's alright. They've already got my face on the video, so they know who I am.
Yeah, so they call it cider notation.
They're just gonna be happy that I'm
But
doing sick
what does
video.
like this like number alone, just this slash number, just tells you what the subnet is already. So who knows like how to make like represent this as a subnet?
Is that where you do like the 29 ones? Like,
Yes.
and then the zeros?
Exactly. So if we did 29 ones and then zeros for the rest, that would be our subnet.
And then you add up the like what the ones translate into, like 25, 25.
So I want everyone to take this IP address and give me the subnet mask, the network address, the broadcast address, and whether or not this is a valid public internet address.
Can you explain real quick what is a subnet mask?
So we're gonna take.
Yeah, so a subnet mask is how you separate different networks out. So this is confusing.
I'm just going to do a representation of that 29.
Okay. What's the best way to explain this? It essentially, so a subnet mask will tell a router or the switch, whatever it is, how much of the IP address is the network address and how much is the host address.
So that's 250.
So it gives you, so it's how like you separate. Let me talk about like, so this is a 5.0.0. So this is your class C private address space. So this says that the first two bits are going to be part of the network address, right? And these are the host address. So it means that you can only, everything on this subnet, everything with this subnet address is going to be part of this network, and it's going to be one of these hosts. So it's a way to, what's the best, I don't know exactly how to.
It's a way to segment
describe
it,
It's a way
right?
to segment your network so that you can have multiple internal networks,
Yeah.
Yeah.
and it
And-
knows the difference.
And what would you call the whole thing? So like if you were to draw a bracket over both the net and the host, what would you call that entire string?
Just an IP address.
Just
Yeah,
the
usually like an
IP
IP address, like if
Okay.
it's like real, like when you look like IP config, like it's going to show your subnet mask with it, because they should be going together always.
Okay.
Just for this like cider notation, like the /29, in case you forgot it, it just means we do 29 ones and then the rest zeros. So remember, this is like binary for an IP address. So if we go back to decimal, it's like 2555. That in the decimal is this. So on a problem, they could say, give me these 5 things for this address, or they could just give you the address and say, this address with this subnet. They're the same things. Obviously, that's a lot easier. It's quicker to write. But why is 2048? We just add 128 plus 64 plus 32 plus 16
I
plus
have
8.
one extra. Got it.
Yeah, sorry. It's,
No, it was
the
fine.
ones are all close together.
I was thinking 2, 6.
So, everyone get that? The cider to here? Yeah, yeah.
So I understand that, but that number you put under that is the, what is that?
This is the subnet mask.
Oh, it is, okay.
Yeah.
And that's the same as 29.
Yeah.
You can write either one as a subnet mask.
You're probably not going to write it because I think this is more like for interpreting the question.
Oh.
But yeah, if you were to, you wouldn't just write a /29. You'd have to write it with the address because it goes together.
That's what I meant.
Yeah.
So wait, just to be clear, our network part, that's the 178 and 18 then? Is that what you were saying over there?
No, so this is where you have to figure it out. So
Yeah.
this is why I gave you guys a harder one, because, okay, so let's just do this one together then. Okay, he already gave you the subnet mask. The network address So first thing we have to do is write this out in binary.
Right.
So
With that.
we need to write your IP address out in binary. This might make a little more sense now. So there we go. Okay, so what's 178 in binary? Who knows? I don't know if I'm going to think about it. It's going to be 128.
So the thing is, like, we might not be able to do it quick, but you guys have as long as you want on the test, so this is 78.
Sick.
101. Yeah. I'm like super slow to this, so like I take my time on the test doing this.
So it's 128,
Or 178. Oh, sorry.
64, 32, 16, 8, 4, 2. So to get it to binary, right, you do 128 plus 32 plus 16 plus 2 is going to give us 178. Does everyone understand that?
Yes.
Okay, so that's how we got that one. Next, 18 is going to be 0, 0, 0, 16, 0, 0, 1, 0. Okay? Oh, geez, I wrote these way too big.
I got you.
Let's do 30. It's going to be 128, 192.
111, 00, 11, 0.
Jeez.
And then
0, 1, 1.
Why is this?
I'm sorry, guys.
There it is. 4 ones. Oh, wait, sorry, not 4. 0. And then 4 ones. And then 4. Just
Okay,
just
where's
like down. Oh,
1,
I guess
2,
we don't
3,
want that
4.
one. 0, 1, 0.
Okay. So now we already know that the first 29 digits are the subnet mask. So we're going to go 29 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29.
There should be 3 left.
Yeah, just
3 left.
And then write the zeros for it too.
So these are the first 29 digits. That means that these aren't going to change, ever. No matter what, for this network. No matter which IP address is on this network, those starting numbers are always the same. So we know that any address on this network is always going to start with 178 dot, we're going to say 18 dot 230 dot, and then this is where the network address comes in. So you take the last digits, anything not part of the network address, and make them into zeros. That's how you get the network address, right? So we're going to do 3 zeros at the end. So your network address is going to be all those numbers that are the same plus 3 zeros. So those first 3 are the same, and then it's going to be whatever this is, an IP, which is 120.
So the subnet is right here. By subnet we mean like subnet mask. That was right here. What we just wrote right here, that's the network.
Okay, can you say one more time? How'd you get the 120? Which numbers?
Okay. Every number that is not part of the network address, okay? So to find the network address, or the network portion of the IP address, you write out the IP address in decimal.
Right, it's the last thing.
It's the digits that aren't part of the 29, you turn them into zeros.
Okay.
And then redo that IP address, just with 3 zeros instead of.
Right, but where's the 120 coming from?
Because you see how these first 5 digits, they have to stay the same? So that last number turns into .0, 1, 2, 3, 4, 1, 2, 3, and that is 120.
You add up the last two. Okay.
That adds up to 120. For your network, it's always zeros. For your broadcast, it's the opposite. For the broadcast, you turn them into all ones. So your broadcast becomes those first 4 are the same, and the last one becomes 0, 1, 2, 3, 4, 5, 6, 7. Which ends up being
127.
127.
Yeah.
So
that's why you can never have an IP address that ends in an odd number, because if your broadcast network ends up being the same.
you can have an IP address that ends in an odd number.
Or not in an odd number. You can't have them.
There was something on the Kahoot, wasn't there? Like you couldn't have the administrator.
Never mind, just keep going.
Oh, that has to be continuous ones.
Oh, I don't know, probably like an hour and a half maybe.
He said 2 hours in class.
Oh, really? Okay. Probably like an hour and a half to 2 or 2.5 hours. The multiple choice shouldn't take long. I mean, they're just like pretty straightforward questions. There's not a ton of them. This part will take long because it's more written and math. But yeah, it shouldn't be like crazy. Yeah.
Should subnet mask always be so end these last 8 like binary digits? Or could the subnet mask like the number there be like 12 and then you'd have
Yeah. I mean, well, it wouldn't be 12, and we'll get to that in just a sec. Let's just finish this problem though. Well, it doesn't have to be, it always has to be like from here over. So to have the 12.
Oh, I think you meant your CID organization.
Oh, yeah, sorry, did you mean like this?
Did you mean the slash 12?
Oh, sorry, yeah.
It can be any number, yeah.
I thought you meant like the whole math was just. Yeah. We'll, let's just finish this and we'll get some more examples or places to do examples. Okay, so network was the portion, and then all zeros. Broadcast was just our portion, which I think was right here, and then ones. And we're almost done because sometimes it might also ask like the first address and the last address. So if this is like the start of our network, this isn't a real address, this is just the name of our network. And this is the broadcast, this is when we want to send messages to everyone on the network. So it's not really a network either. So where is the first one, where is the last one?
one after 121.
Yes, one after one before. So in this case, the first address on our network would be this whole thing, 121. Last one would be this whole thing, 126. Okay?
Yeah, network and your broadcasts are cannot be hosts on the network.
But you can kind of think of it as like the ending point and the starting point. So the first one is just like the one right after that, and the end is just one right before that.
So you could only have that many hosts,
Yeah.
IP addresses.
Yeah, so this
on
would be
this network.
this network would be very few hosts.
Yeah.
Supersedes like 5 or whatever.
Yeah.
Yeah, could you have a subnet mask of like 2 or 3?
Where you do like a /2 or /2.
And then you have to have all of those numbers to get your broadcast and your network, and that would give you a huge range.
Yeah.
Okay.
When it comes to like, is it like a valid? What do you mean? But do you mean like a valid?
So is it
subnet?
valid over the? No, is it a valid host on the internet? Which
Oh,
means,
yeah.
Which means that it's not a public. I mean, it's not a private IP address, which is not, and it's not the broadcast or the host address, or the broadcast or the network address. So it's good.
Yeah.
Okay.
So yes.
Good. So if we're given another IP address, please compare each of these, those reserved ones, each not valid.
So if it's a private IP address, it's not valid over the internet.
Right.
Which could be a question. Does that make sense? Is that what you're asking?
Yeah.
Okay, what about
Isn't it
this?
private?
Is this a valid subnet mask?
No,
Why is it not valid?
because there's zeros.
Yeah. So if I were to write this in binary, it would be zeros, a bunch of zeros, and then a bunch of ones from here, right?
Yes. Yeah.
That's, you saw me right, so you know what they are. Subnet masks, they're always just like a bunch of ones, and then a bunch of zeros. So it's always a bunch of ones, a bunch of zeros. Whether it's like a ton of ones or a ton of zeros at the start and the end, doesn't matter. But you can't have like a mix. You can't have like a bunch of zeros and then a 1 right here. That's not going to work. And so because of that, the subnet masks will always end in like a 128, 192, 1 something, 248. It's pointless to memorize those as long as you can like visualize as long as like I have ones and then zeros. So usually it starts with like a 255 for a couple of the octets and then goes over to something that has ones and then zeros after. That's like a simple question, and he could just say like, hey, is this a real subnet? And if you don't know what you're doing, you'd say, yeah, it could be.
That is a valid subnet.
Yeah.
That would just mean that that one host is the only.
Yeah, it's just on its own network.
We're not really a network, it's just a single computer. It is valid. /32. Yeah.
So figure out whether it's that to check to see if it's all ones and all zeros? Or-
No, it's valid over the internet if it's not a private IP address.
Yeah, so if we did,
If the address itself isn't private.
if this was like, we could like find a subnet for this, but it wouldn't be like valid on the internet because we know this is a class B private address.
You just might memorize it.
You just have to know
You
the
just have to
ranges.
memorize those ones.
Yeah.
A lot of people are leaving. I think I'm not doing anything tomorrow, so I might just do like another like just subnet review. Would anyone want to do that? Yeah.
Is there more, or did you cover the basics?
This is like the basics, but we like blew through it.
A lot of stuff.
What's up?
You wanna like,
Yeah,
on
like,
the
see,
slides,
there's,
something,
like,
do like a practice problem?
Yeah, let me show you something that
What's it called?
I think is super helpful.
Yeah, like all the practical things, use like a graph, like it's like. green.
This is on the slides. He has a link to this. It's a website that literally does that for you.
Yeah.
Yeah, we find whatever.
It works. It works. Get rid of that last.
There's like other. I think someone in the class like sent out one earlier. So the only thing, it'd be nice if you could type in your own, but you can't. But new problem. We don't have time to go through this all the way. But I mean, this is the questions we covered.
So when you click on new problem, it gives you an IP address with the notation on the end, and then you give it all of those.
Yeah, I
and then
mean, you can
check
type
it.
this in or just write it in a notebook and then just like shows you the answers.
Does it not show the subnet?
No, it doesn't. So this doesn't show the subnet mask.
The other one shows the.
But if you get the rest of it, you probably
Does the
know
other one
the
that someone
subnet.
sent out?
I posted that.
Oh, is that you?
It's got
Okay.
it's got the subnet mask.
Yeah, it looks pretty similar. So maybe do the one that was sent out on Slack. I guess it's better. But basic idea is you can just like practice a bunch of these. And yeah, I will. Yeah, I think like my class like ends at 5 tomorrow, so I can like. What time works best for people who are here? Like 6:30, same time-ish?
6:30 works good.
Okay, I'll Slack everyone out because Slack out to everyone because. Yeah, I will too. My laptop's out, so I wasn't able to do that.
Thank you guys.
Thank you.
Sorry for like
We'll probably,
everything.
we'll Slack out, we'll probably put the slides on Learning this week, under the content tab, but we'll send out a Slack message when we do it.
Yeah. And yeah, sorry, there is like a ton of material. So
If you have any questions, come ask us right now.
I have.